so stupid.
Okay, we're going.
What are we doing?
Firstly, congrats to Mr. Grifster for winning the gold medal.
Woo!
That's a and well, Griffin's. I already told
Okay.
Trey via the medium of boomer language, talking face to face. So, but the Grifster's watching on Twitch, so
He'll see this 2 weeks later.
no. I think he watched a couple of them fairly
Recent.
like only within a couple of days of them being posted. So. Anyway, Griffin, if you're watching this, congrats, bro. All right. Last thing to cover.
Yeah.
You. Substitution. Yes. Soulja Boy wrote a whole song about this. JB.
Friday.
2 days.
420.
Just cool out. Just a prank, bro. Just a prank, bro.
Yell him out.
Paul, you should post like a whole bunch of tests on 420.
I don't know. I'm thinking maybe Thursday. Tomorrow we can have a work day. You can knock out the rest of the problems. I'm going to hopefully cover it goodly enough today that you're like, oh, it's actually not that hard. This is probably the more complicated thing we're going to cover. It's one of those things where you might possibly have to just accept the process. It may confuse you. You might have to just accept the process, but it might make perfect sense to you. So I'm just giving you a fair warning. This does tend to be on the more confusing side of things that I cover as well. All right, ready spaghetti. Maybe actually, now that I'm thinking, maybe as a quick lead into this, we should do one more just little example-y wamply of one where we have the U prime like we like to have it. Maybe like 21. I mean nothing. 21 like F or something. Maybe 21
I haven't
D.
done that one yet. Or that one.
Sorry,
Either of those.
Okay, can we do D?
21 D.
I haven't done D yet.
Oh, there you go. Just for you, Lillian, because you're worth it. Because you're worth it. Okay. So 21D looks like this. First, I want to rewrite it. Okay. So the idea is you go, oh, wait a second. This looks a lot like a U prime times U to the N type question. We know if we can get it in this form, we're happy because an integral of this form is very easy compared to other integrals. Like this is about as easy as an integral can get, other than just being of the form x to the n. Okay?
It needs to be negative.
Good.
Negative. 5 needs to be negative. Because you.
Oh, thank you. Okay. I was like, did I write that wrong? I was like, yeah. Okay.
The questioning is.
So then we go, okay, great. As long as it can be written in the form u prime times u to the power, then we're good. So what we notice is we go, oh, this is almost the u prime that we want, right? Because this guy is the u. So what do we wish lived there? A 4. So you make it so.
Engage.
But I can't just put a 4 there. I mean, what I just did was I made the integrand, the nougat, half as bigly as it was before. That's not allowed. But as long as I do this, then I'm balanced out, right? 2 times 4 makes 8, the thing I started off with.
Yeah.
Are you all cool with that?
Yeah.
Mr. Paul's favorite thing in the
My
world.
mom put my sandwich in tinfoil and then the tinfoil sandwich in a bag.
What's important is that you folded up the bag before putting it away. So thanks for the extra crinkles. All right, moving on. Now this says u prime times u to the n. So we can apply this idea, but the 2 is still out there, so don't forget the 2. There's still a 2 out there.
Those.
So now this guy, just the integral part, follows this rule. So we go, it's going to be u to the negative 4 divided by negative 4. I like writing it in the u form just because I think it just helps you avoid mistakes. So anyway, we have 2 times negative 1/4, which is negative 1/2. Well, hold on, let me back up. I might take an intermediate step to say, okay, what is this? This actually says negative 1 over 2u to the 4th. Is everyone okay with do this.
Mhm.
And then my very final step is to say, well, technically the question never talked about any u's. I used something that I made up to help me think about the problem. So really the answer is -1 over 2 times the quantity 4x minus 1 to the 4th plus a constant. So this is my actual answer. Yes?
Is it okay if we wrote it as -1/2 times 4x minus 1 to the -4 plus c? You didn't rewrite the fraction, you just left it up there.
That's okay. I would just make sure. You can do this though, because if the question says, write your answers in a way where with all positive exponents, for example, that's a pretty common thing you might see. Is write your answer, make sure your answer has only positive exponents. Then, make sense. It's certainly not wrong, but it's just it could be simplified a little bit nicer.
Okay, so,
Hold on, Aiden had a follow up. What?
sorry. Why does it 2 and not 1/2? Because don't you multiply it, you have to multiply the 1/2 to get it before?
Yep, so if on the inside I'm making it half as big, then I'd have to counteract that by doubling the outside. So for example, let's say suppose for some reason I had to triple this number, I would multiply by 1/3. Or suppose I had to make this, divide this by 5, I'd have to put a 5 out there.
It's like 30 divided by 2. So.
Yeah, I made 8. Me personally, I don't really think of it that way. I think of it just, I'm like, I put a 4 there because that's what I want there to be there. And then I ask myself, well, what has to be out here so that this times this makes that? Because ultimately, I don't want to change what I had originally.
I think of it as like factoring, like you're just taking like it out of the, or I mean, sometimes it's gonna be like opposite of that way. It's not like you're taking a number out, but I still think about it as factoring. Like that number is being taken out of that number, and then you're gonna put it back. Does that make sense?
Yeah, 8 as a 4 and a 2 is factors, so you just pull the 2 out. Yeah.
Yeah.
What's up?
That's what I meant.
When I did mine, I got 32 for the number, so like I think I did 4 times 8. So do you just replace the why do you not like multiply them like that if these on the outside? I thought that's what you
So the 32. So wait, hold on. Was this your first step to do that?
Yeah, but instead of 4 I got 32 because I thought you like the derivative by 8.
So you got a 32 right here.
No, like on the inside after that little s.
Oh. So you had a 32 here.
Yeah.
So I imagine you would put a 1/4 out there.
Yeah, because I thought.
So the problem with that would be, we want this to read. Our goal is for this to read u prime times u to the n. So what's our u in this case? Well, our u is 4x minus 1. What might help you keep things straight is to actually write out like my u is 4x minus 1, so my u prime must be 4. And that'll help you just visually see like that's the thing that I want to live right there. I'm not sure if that answers the question or.
So you just like replace the 8 on the 4 basically.
Yep. I say, again, it all comes back to this. I want this to be u prime times u to the n. So if this is u, I need this thing to be 4. And I'll do whatever it takes to make that a 4. And so what we were just talking about up here was like, depending on the way you want to think about that, my advice, if you're getting confused, is just to put the 4 there. So once you identify that you need a 4 there, you put it there. Then you say, take a step back, little breath. You go, okay, I changed the 8 to a 4. Okay, but I need this. I need the 2 multiplicative constants to multiply up to 8. So what has to go here? Well, it's got to be a 2. Does that help a little bit? All right, let's move on. So there you go. We're gonna have some work time today, hopefully. I don't wanna, I'm gonna go over several examples of this. Maybe that'll eat up all the time, I'm not sure. We'll see if you have questions, but. So let's compare though. I'm glad we went over that, because now compare these. This guy is a lot different than this guy. Let's see, why is that? Well, yeah, what's my u? My u is this thing. So what's u prime?
Should be one.
It should be 1, but there's this pesky x out there. What, like, we're not going to be able to get rid of him. If you're thinking I'm going to move him outside the integral, that's clever thinking, but that is not okay. That's not going to work. Okay, that's what last week. I know some of you guys maybe were getting confused. I was talking. I know Rafe and I were talking about that last week, a bit of this idea of like, why can't you kind of pull this x out? And it's pretty easy to show with some simple integrals. Like, I'll show you a really quick one. Integral of x cubed is an easy one. You'll see you can't take this and just like pull out an x. Those are certainly not the same thing. So anyway. Okay, or maybe just take my word for it. The only thing you can really modify here is constants is what. So anyway, let's get into it here. Let me erase this. But does everyone understand how this is fundamentally different than this one?
Mhm.
Yeah.
How it has an extra x. So how do you deal with that? So this is a special class of integrals that you encounter in calculus that requires something called u substitution. All right. So here's the idea. I'm just going to walk through it here. So this is the u. So it's pretty standard to write it out when you're going to do this. So you go u is x plus 1. All right. So what is du over dx?
It would be
One.
x times x prime.
It would just be 1.
Yes.
This is also known as u prime, right? So because there's no
Oh,
x
sorry, I'm thinking
prime,
of the, yeah.
yeah, if we went like du over dt, then you'd have an x prime. But since it's what's the derivative of this with respect to x? And you might be wondering, hopefully you're wondering, well, why? How come all of a sudden you're using this notation? You're not using u primes anymore. Well, the reason is you're going to take this expression and modify it so it looks like this.
Oh.
Everyone okay with that? This is, if you want to get super duper 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 technical, it's not a fraction, but it basically is.
Thank you.
Okay.
You need to know that.
It's one of those weird things where like down years from now, if you keep studying math, you might go, wait a second, like we've been treating this thing like a fraction the whole time, but technically it's not. So I'm just giving you a heads up. That like you can treat it, for our purposes in this class, you can pretty much always treat it like it's a fraction, okay? Meaning effectively I'm just sending the dx to the other side like I would with a basic proportion.
When that happens, Jay Hall, I'll send you a Mr. Toadman.
There you go, exactly, Mr. Toadman. I was watching The Mandalorian this weekend with Paigey, and there were so many Toadmans. It was crazy. There was a whole episode with frog people.
Wow.
I got 3 stuffed frogs.
That's lit. Nice.
Sorry, I'm really excited.
Mandalorian themed or just generally just
No.
Just
We
for
really
frogs.
have matching frogs.
It's not the way.
that's lit. That's not good. Anyway, so there's one more thing I'm going to do over here in this little box of information is I'm going to take this and also write that this is true. Do you guys agree that if that's true, that's true?
Yeah.
Yeah.
Okay, so now what's going on here? So if you're like, what's going on, then that is a natural reaction. All right, so this integral, now I'm going to perform the u substitution. Meaning I'm going to substitute so that this thing has no more x's
Oh.
anymore. It's going to be all of u's. Okay? This guy, what do I replace him with?
U minus 1.
U minus 1. Yeah. I replace this guy with u. And then that u is being raised to the 6th power. And then here's the best part. If I wrote dx, I would not have gotten rid of all the x's. But luckily I did this earlier. So the dx can be replaced by a du. Now, There have been a lot of occasions in this class where I tried to show you how like the choice of x is just arbitrary, right? Now this is now equivalent to if I had just written x minus 1 times x to the 6th dx, right? It's just, so now this whole integral is in one variable. How do I do this? Well, let's do it the old-fashioned way. Distribute this term in. So u times u to the 6th makes u to the 7th, and then u to the 6th times 1 is u to the 6th. Again, du. So then you say, oh, great. This is going to be u to the 8th over 8.
What?
You did the.
Oh, okay.
Now I'm just using, you got to now think back a couple a week. This is not even this rule anymore. I should probably erase it. This isn't even like, notice on this rule, it utilizes the fact that it's u prime times u to the n dx. We don't even need this anymore now. Because ultimately what this is just utilizing this fact. The fact that
Indeed.
is that apple to the n d apple is just apple to the n plus 1 over n plus 1 plus c. Yeah, is that a yeah?
Yeah.
Yeah. hold on.
Yeah.
I could have used
Writing
x's,
it
of
better.
course. I could have used u's or bananas or q's or grapes. You get the idea, hopefully. All right. Green. Okay. Now my very last step now is, well, the original question didn't have any u's. Use something I made up to help me with the problem. So now I go, okay, well, my answer is just 1/8 times u to the 8th minus 1/7 times u to the 7th plus my constant, and then that u, forget the original setup, that u is just an x plus 1.
Well then. Can you put it on?
There's the final answer. What?
Can you put it on top of the fraction?
You could,
Okay.
if you want.
I do.
You do. All right.
I do be like that.
Do be like that. Now, I will show you something.
Well.
That I wouldn't say this is interesting, but it maybe is. It confirms the result in a nice way.
Oops, I cut through my answer.
So let's not forget the big picture here, guys. Who dat?
You.
He is the antiderivative of him. So that means the derivative of this guy should be this guy, right? Let's try it out. I'm gonna take the derivative of this real quick using the chain rule. So the derivative of him would be 8 times 1/8, which is 1. And then x plus 1 to the 7th. By the way, what's my u prime? It's just 1. And then minus 7 times 1/7 is 1 again. And then x plus 1 to the 6th. So there's the derivative, but is that the same as that? Well, it is. If I factor out the common factor here is x plus 1 to the 6th. And so if I factor that out, well, factor out x plus 1 to the 6th from this dude, and what's left over? X plus 1. What's left over from him? Just that -1. Cancely bobancely,
Whoa.
and you got the thing you started with. Is that a yeah?
Yeah.
Yeah. So what you might, the reason I'm showing this to you is one, it's interesting too. If you go to check your answer on this, it's pretty likely that if you take the derivative, you might not immediately get back to the thing you started with. So it might not be entirely obvious that your answer is correct. How are our feelies?
Good.
Feelies? Feely report? Billion? No, are we down? Feelies down?
Yeah.
Oh, that's bad.
So you took x plus 1 out of x plus 1 to 6, so shouldn't this be -1 times 1? Like, what are the brackets?
Oh, well, let me rewrite that. So let's say I rewrite this term as x plus 1 to the 6th times x plus 1. You agree with that? And then this guy as x plus 1 to the 6th times 1. And now here's my common factor. So I factor that out as x plus 1 to the 6th. And I use square brackets. I didn't have to use square brackets. That was just, I don't know. But then when I factor out that common factor, what's left over? I got the x plus 1 from the left term and the minus 1 from the right term. Let's do another example. Is that yeah with everyone?
Yeah.
Yeah. Okay. Let's do the one right below it.
B?
B.
There's a B.
B is in based.
Based.
What you do to the turkey on Thanksgiving?
Yes. Yes.
What do you say?
Bake it.
Bacon?
Bake it. As in
Bacon and
putting it
eggs.
in an oven.
Okay.
Heat
27.
it.
You know, nice and sharp.
Ew.
Sure.
Charred turkey. Yeah, that sounds fantastic.
Okie dokie. Yeah.
Oh, that's a good.
Good time for questions. What's up?
Well, it's about this, but
About this one?
yeah, because
The one.
du over dx equals negative 1.
Yeah.
So would du equal negative dx?
That's a yeah.
Negative du equals dx, but how would you put that in the equation? Would you put positive du or negative du? Does it matter?
It's going to end up being negative because, like you said, dx is equal to negative du. It's helpful to think of that as negative 1 times du. And then you can just use that, take that negative 1 factor and move it wherever you want. So you're ahead of me here. That's good. So let's identify our u. Hopefully you caught on what Alyssa said. It's 100% spot on. Everything she said is like, she's kind of thinking about this stuff over here. So the u is 4 minus x. Great. Which means that's equivalent to writing x equals 4 minus u. Everyone's cool with that, right?
Yes.
Then we can say that du over dx. So just take the derivative of this guy with respect to x. You get negative 1. Are we okay with that?
Yeah.
So the way you can write this is that du, now ultimately I'm trying to replace a dx, right? So I certainly could write this as du equals negative 1 dx, but it makes more sense to put the negative 1 over here. Do you feel okay about that?
Yep.
Yeah. So dx and du are basically just going to be opposites of each other. In plain language, it means a small change in x would produce an equally bigly but negative change, but opposite change in u. Which hopefully that makes sense given that if you were to graph u versus x, it looks like this, right? Anyway, you don't need to know. You don't need to see that. It's no problem. So we got all our information. This is all the info we need. So time for u substitution. Okay. So this first one is 2 times x. So what do I replace the x with?
4 minus u.
4 minus u. All right. And then let's replace this with u to the 5th. And then let's replace the dx with negative 1 dx. Oh, sorry, du. Go back. My bad. All right. That was the critical part of the problem. Yeah.
going back to the negative one from DU.
Mhm.
Why wouldn't it be DU over negative one instead of negative one times DU?
That works too, but dividing by -1 is the same as multiplying by -1. That'll be extra important if this number was like a 2. Which is like, for example, if you had, say you had du over dx equals -2, then you'd have to be very careful to make sure that this turns into that. With -1, dividing by it is the same as multiplying by it. Everyone okay with that? That's a good question.
Mhm.
Okay. So now, all right, be careful here. I got a -1 multiplied by a 2. We could just pull that out of the integral, right? Because it's a constant, or it's a multiplicative constant, right?
Mhm.
Okay. And then what's left over? We got
4 e to the 5th subtract e to the 6.
very good. Or you could have kept the -2 inside. It's totally up to you.
That's what it means to you.
Oh, thank you. What was that, Lillian?
Nothing.
Okay. All right, moving on. So if it makes you feel better, we can keep the -2 inside.
And you can just make
No,
that
I'll
just
just-
8 and then the negatives are positive to e to the 6. Right?
Look here, class poll. Who likes? Wait, this is choice A. Choice B would look like this. Which one makes you feel better?
Choice A.
B.
B. A. I go with A.
Ultimately, what's important is you understand both. Really.
I don't know. The
Uh,
second one makes more sense to me.
Okay. Because otherwise, you just have to make sure that -2 gets multiplied onto whatever you end up with. Okay, we can go with choice B. It's fine. Poor Lillian.
I want to C.
Okay.
C.
All right. So then,
So then you just
2.
multiply everything by everything.
by the way, guys, if you find yourself getting confused with the algebra side of things, what I'd recommend is just take that extra step and write it as -2 u to the 5th times this. It's just one intermediate step, and will hopefully alleviate any confusion for you.
Okay.
Are we okay with this?
Yes.
Yes. That's what I got.
Our good friend, the distributive property. Now there's a good stuffed animal.
Friend.
Can I get a distributive property stuffed animal? Maybe one of those squashmallows that they have at Smith's, the squashmallows.
What?
You guys know what I'm talking about?
Oh, yeah.
Squashmallows.
Yes.
Squashmallows.
Yes, J.O.
Squashmallows.
Okay.
All I
The
can think of
amount
are
of times
marshmallows
you
like
say it
squash.
does not equal to like more understanding.
Squashmallows, Jesse. Squashmallows. Okay. So what you do is you apply the squashmallow theorem. So you squashmallow this up to the squashmallow power, and then divide by that new squashmallow. Okay? And then this, samesies, 7th power. Okay, now I ran out of room. I painted myself into a corner. That's okay. I'll write the final answer in red up here. So this here, -8 over 6, is a -4/3. Then we got u to the 6. How about this? 2/7 times u to that power. And then, of course, the u's really are 4 minus x's. That's what we said at the beginning.
Yeah.
There's our final answer. Not the prettiest expression you've ever seen, but it's certainly a lot nicer looking than if you had to expand, like binomial expand this, and then you'd have 6 terms.
3 too many.
Yes, certainly. Should we keep going? Yes, of course we want to keep going.
We crave knowledge.
We crave.
Crave learning, sorry.
Crave. We crave squashmallows, right? Right, Ave? No?
I just can't get it out of my head of marshmallows that like taste like squash. That is the only thing that's coming to my mind when you say that. And so whatever you say.
No, it's more like a marshmallow that you squash.
Okay.
Not that tastes like squash. It's a stuffed animal.
Yeah, I haven't been to Smith's in a while. This is where you're referencing.
Smiths.
Laura.
You made a squishmallow?
Is that what it is?
Yeah.
I thought they were squashmallows.
No.
They're squishmallows?
Yeah, squishmallows.
If only someone had told me.
Well, somebody did.
I just did.
I'm sorry, I don't
This is like my mom and I's intellectual conversation.
I don't recall
about
this.
the technical
Okay.
term
That's
of
like-
how mushy something is.
I'm gonna skip. I'll save C for you because C will be a nice practice after you see A on the other one. This will be the last one I do today.
28A.
I'll be back. Oh, dang it. Dang it.
28
No.
A.
I'll just start now. What? I'm so cold. Oh, yes. The dinner. We're talking, of course.
All right, we feel okay about what this says? Okay. What's our U? 2x plus 1. Okay, great. So while we're at it, sometimes I think it's nice to do the derivative before you do the, like, get this out of the way. That's my U. So my derivative of U with respect to x is 2. Very good. So now let's rearrange that. Let's be very careful. Ultimately, I'm trying to replace this dx. So this says that my, it says that my dx
Oh,
is half as big as a du.
I just like think that it's always going to be reciprocal.
Are we
Is
okay with
the
that?
safe way of thinking? Okay. I'll just go with that way of thinking. Seems to be a safe way.
Well, if this is throwing you off at all, just
No, I think I figured it out. I figured it out. It's okay.
you're just solving a proportion here. So
Yeah.
Yeah.
Solving for this guy. All right. Do you feel okay so far? Now, this says that x, if I subtract 1 and divide by 2, I get this.
Oh, goodness.
Everyone okay with that? Or I might have wrote that. Or exactly, I might have written that as u minus 1 over 2.
Okay,
Totally.
thank God.
Totes my goats.
Totes my goats.
Totes mixed squashmallows.
Too many syllables.
Oh,
Are we sure we're okay still? No one's confused?
Not yet.
Okay. All right, let's do the substitution. Substitution. So 6 times x. Now this is where when you're doing the work here, there's certainly nothing wrong with just replacing the x with your expression, but you might think a step ahead and just replace the 6x with 3u minus 3. Does that make sense?
No.
No? I don't know. That's okay, then don't worry about it for now. That's fine. Now this is my u to the 1/2 power, and then dx is 1/2 of a du. And then we maybe have a tepid rejoicing.
tepid rejoicing.
We got there's no more x's. It's all u's, but it still looks a little confusing. So let's okay. Let's be really careful. All right, so and that's up to you kind of how many steps you want to do at once, but you can do 6 times a half, right?
Makes it-
That gets you 3. And then you can distribute the 3, or let's break it up into 2 steps. 6 times a half is 3 times u to the 1/2. And that's being multiplied against this expression. Oh man, what was that? GameStop rises.
Or just crash.
Just crash. That doesn't sound
That's
like
what it
a,
does sound like,
a
a crash.
joyful.
That's how
How do we- Does that feel okay? Like
Yep.
Analyzing, you know,
What if you put it in the other form?
u minus 1 over 2?
Yes.
At a certain point, you're going to want to break that up
I will
because
break it up.
if you looked at the last 2 questions we did, we always end up with like individual u terms. Yes, Lara.
So where do you get the u and the 1/2 again? Is that just a?
Right here? Yep. So this 2x plus 1 is our u. So this reads square root of u, and that's the same as u to the 1/2 power.
And then the 1/2 is, where's that?
This one?
The 1/2, like.
This one? This one?
Right. No.
The other direction.
Right.
1/2. The U, the 1/2. No, left.
This
Where'd
one?
that come from again?
That came from when we set up our u, we took the derivative of that with respect to x to get this. Does that make sense?
Yeah.
Sure. And then this, if you basically like solve it for dx, send him up there, divide by 2, you get this.
Oh, okay.
Or any more questions? Anyone else? Anyone got?
No, I've got-
These are good ones. These are good questions to ask. Yes.
Why don't you have, when you have the distributing signs up there, why don't you have that into the 3 halves?
To what?
Your 1/2 u minus 1/2, wouldn't that be the 3 halves since because it's the way it's distributed?
Well, we're about to have a 3/2 power once this multiplies by this. But right now we have a multiplication of 1, 2, 3, 4, 5 things. So I've just rearranged that multiplication. That's just commutativity. Right? So what I did was I went 6 times a half times this to get this expression. And this guy's just chilling.
Okay.
D is
Bird,
chilling.
one stone.
Let's distribute. 3,
That's what that is.
so this times this. 3 times a half is 3 halves. Still an integral. And then u to what power? Right, because 1/2 plus 1. Then 3 times a half.
Save the ocean practice. Whatever it is.
Okay, is everyone cool with that last step there? Yeah. So now we can have a real rejoicing because we're like, oh, we have this in the form of u to the n, u to the n's, 2 individual terms. So we're just going to take this guy, and this is another kind of intermediate step that can be very helpful for avoiding mistakes. What's the new power going to be? 5 halves. So what are we going to be multiplying by out here? 2 fifths. Okay? Then minus, this guy's going to be a 3 halves power. And so what are you going to be multiplying by? 2/3. So my final answer, yeah, that's going to be a nice one. That's going to
I
cancel
like
out.
that one.
You don't like it?
I do.
Oh, okay. So 2 fifths times 3 halves, 3 fifths. 3/5 times my u was 2x plus 1, to the 5/2 power, minus 1 times u to the 3/2 power, plus our magic constant.
Nice.
I forgot we have to put it back in. Alrighty.
See some weird grapes. Grapes.
Are you still on about the grade?
It's not great. It should look like-
Is it the one with the? I think that just happens because
We
they
just
like
made
freeze it.
a decision that any food
Yes.
that comes from this facility is not going to be the highest
And then they
quality food.
And so then the
Ever.
skins just don't.
It has never been that case. However, this year
Unless I
it's
make, unless
exponentially
we put
worse.
the lettuce in.
Yeah.